Hello, so I welcome you all to this session of solid state chemistry for class 12th, and so now I am taking your chemistry class as well. I hope you will like it in the same way as you have been liking my physics class. So, solid state. So, there are basically three states of matter, you know, na? The first one is solid, the second one is liquid, and the third one is gaseous state. Now, why do they have different forms of state? So, you know, anything is made up of atoms, and when atoms combine, they form molecule, and these molecules, when combined together, form a particular compound. Now, this compound can exist in the form of solid, in the form of liquid, or in the form of gases. So basically, the structure of molecule is determining whether it will stay in solid state, or in liquid state, or in gaseous state. Now, so the arrangement of molecules is what is deciding the state of matter. So in solid, the molecules are actually very closely packed together, and that is why they are in a solid state. Whereas in liquid state, in gaseous state, the molecules are very far away from each other, and there is no force of attraction in between them, and they are very far away from each other. So it is gaseous state. And liquid state, the molecules are in between the solid and the gaseous state. So they are together, not very far away, not very close. So they are liquid in nature. Now this you can understand more clearly by imagining the best bus. So in best bus, if you see in the rush hours, or in the local in the rush hours, there are we the people are very closely packed. So there is no chance of movement of our in between the local or in between the bus. So if we consider ourselves as the molecule, so we are so closely packed that we cannot move from one place to another. That is what the solid molecules are there in the solid state. So what can we do merely? Merely we can do like this. We cannot go from one place to another. And that is how the solid molecules keep on vibrating at its own position. So there is no kinetic energy, but they keep on vibrating. Whereas in the liquid molecules, so imagine the Saturday, and we can move from here to there a little bit, and this is how the liquid state exists, because the solids do not have so much intermolecular force of attraction, and the molecules can flow, and this forms the liquid state. Whereas in gaseous state, it means that gaseous state is like this COVID situation where only the doctors are traveling through the local, so there is very minimal rush in the train, and all the molecules are free to roam. So this is how the gaseous state is there. So molecules have negligible force of attraction. Now there are properties, various properties associated with solid, liquid, and gas. You know, a solid has a rigid shape. So if this is the shape of solid, I place it on the desk or I place it on the table, it will remain in its shape. So this is the shape, that is the rectangular shape. Whereas liquid does not have its own shape. If you put water in a Sprite bottle, it will take the form of a Sprite bottle, and if you keep it in a mug, the same water will take the form of a mug. So they do not have a definite shape. Whereas gases, absolutely no definite shape gas has, because there is nothing like empty thing. Okay, so if there is an empty bottle, this means the bottle is containing gas throughout its volume, that is, it is completely filled with gas. When it is not filled with gas, when we say it is vacuum, so vacuum is the state where there is nothing, and in general, if there is nothing inside something, then there will be gases present, and gas takes the entire volume. So if you place water here, so water can take up to this much volume, and it will acquire this much shape. But if I take out the water and it is empty bottle, suppose, then the bottle will be throughout occupied with the gas, so the gas will be filled up in the entire bottle. Okay, So the gas takes the shape of the substance or takes up the entire volume of the thing, and liquid just takes the shape of the thing throughout the volume to which it is filled, and solid stays in its own shape. Okay. So more clearly, if you want to see this, I hope this is basic thing. So this, if this is my solid thing, then it will stay in its place no matter where I keep. I can keep it in a ball and it will stay in this shape. But if this is my beaker and I place liquid, then the liquid will take the shape of the beaker. So the liquid will be filled like this if this is my beaker. But if there is nothing in the beaker, then that means it is completely filled with the gases. So it is completely filled. Up to here it is filled with gases. Okay. So this is how the solid, liquid and gases exist. Now here we will be basically studying about the solid state. So what are the general characteristics of solid? First thing first, they have definite mass and volume and shape, which I said earlier, that suppose it has a particular mass of suppose 500 grams, it has a particular volume, this much length, this much breadth, this much thickness, and its shape is fixed, that is rectangle. So wherever it will go, it will act as a rectangle until and unless it is broken into pieces. Secondly, the most important thing that describes the solid, that it is a solid, is intermolecular distance. Now intermolecular distance, that is the distance between the molecules, it is called intermolecular. So the distance between the molecules, that is intermolecular distances, are very short, in the range of nanometers. Intermolecular forces, that means the force between the molecules. So intermolecular forces are very strong. They are so much strong that they cannot go far away from each other. They are always close to each other. So intermolecular forces are strong, and their constituent particles, that is atoms, molecules or ions, have fixed position, just like a best bus in a very rush day. So it have fixed position and they can only vibrate or oscillate about their mean position. They cannot travel from one place to another. And they are incompressible. They are incompressible means what? They cannot be compressed. They cannot be compressed. If I try to compress it, I can only break it. I cannot compress it. So this is rigid. Rigid means what? If I hit these two, so it will make some sound here. I am not hitting it hard because it will break, but it is making some sound. So it is rigid. Okay, it is not compressible. But you see, even liquids are not compressible, but gases can be compressed. So when you take a needle and you see what doctors do, when doctors do give syringe or give injection, what they do, so they first compress that plunger, and in that way they are actually compressing the gas, that is the air inside the syringe, and then the liquid comes. So they are compressing the gases. So that means that the gases can be compressed. Why? Because the molecules of the gases are far away from each other, and when I apply external force, then it can be compressed. But since the molecules of solid are already closely packed, so even if I apply force, they cannot compress each other any further. So this is the criteria. Now there are, again, if there is solid, then there are genuinely different types of solids. So we'll be studying the classification of solids. So solids are generally classified as amorphous and crystalline solids. Now you see what is crystalline and what is amorphous. So crystalline solids can be classified. Solids can be classified as crystalline or amorphous on the basis of the nature of order present in the arrangement of their constituent particles. Now this is a very big term. The basis of nature of order of their constituent particles. It means what? It means that if suppose you take the example of a Rubik's cube. Have you seen the Rubik's cube? So what does it have? It have tiny cubes arranged in a particular pattern, various colors of tiny cubes arranged in a particular fashion. So each cube when combined together form a very large cube, but it has a particular pattern, one cube over another cube, isn't it? So it has a particular pattern and it has a particular order, means first 6 cubes here, then in the next row 6 cubes, then in the next row 6 cube, so 3 rows there, again in the next row 6 cube, next row 6 cube, next row 6 cube, so 3 rows here. So throughout they are arranged in a particular order. And this is how the crystalline solids are arranged. It means the molecules are arranged in a particular order. A crystalline solid usually consists of a large number of small crystals. Means small crystals will be there and a large number of small crystals will combine, each of them having a definite characteristic geometrical shape. That means each one of them will have a particular geometrical shape and they keep on going onward and onward to form the complete crystalline solid. So if you want to see the example, you see here this figure, you see this is a hexagon and this is another hexagon, this is another hexagon. So three hexagons together, then two hexagons above it, then again three hexagons, then again two hexagons above it, and then again three hexagons. So if you see, there is a pattern 3 2 3 2, isn't it? 3 2 3 2 is the pattern, and every pattern has hexagon with definite number of molecules. You see 3 plus 2 plus 2 plus 3 plus 2 plus 1. Same here, 1 2 2 2 2 2 1. Same number of molecules in each hexagon is present. Have you noticed it? So there is a, so if you consider this small hexagon as one particular crystal, then several layers of crystals is forming the entire crystalline solid, isn't it? So they have a regular pattern and they are form of definite crystals. So that means the hexagonal crystals are forming the crystalline solid. Whereas, so we can say that a crystalline solid usually consists of a large number of small crystals, each of them having a definite characteristic geometrical shape. Here the geometrical shape was hexagon, isn't it? Now it is also saying that in a crystal, the arrangement of constituent particles, what is constituent particles? Atoms, molecules or ions, is ordered. So you see now, the constituent particles was ordered. Order means what? A particular order is there. It means 6, again 6, again 6, again 6, or 6 2 6 2 6 2, or 1 2 3 4. It is also an order. It is increasing order or decreasing order, or there must be some progression should be there. Okay. So in a crystal, the arrangement of constituent particles is ordered. It has long range order. Long range order means for a very long range it is following the same pattern, that is called long range order. There is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal, means it is repeated for periodically. So 6 2 6 2 6 2, it is getting repeated. Okay. Now amorphous solid, what does amorphous solid say? An amorphous solid consists of particles of irregular shape. Particles of irregular shape. See, atom is what? A spherical shape. Now when the atoms are forming a crystal or a particle, it will be of irregular shape. Here you see, this is some shape, not hexagon, some irregular shape. This is again some irregular shape. This is again some irregular shape. This is again some irregular shape, and they are all joined together. So an amorphous solid consists of the particles of irregular shape, and the arrangement of constituent particles is only atoms, molecules or ions, has only short range order. Short range order is what? See, this red green red green red green red green red green red green, and here green red green red green red. So short range of order is there. There is no long range order, means there is complete irregularity there. So this is what amorphous solid is all about. So a regular and periodically repeating pattern is observed over a short distance only. So for a very short distance you can observe a regular pattern. It means there is irregular pattern. We can say overall the pattern is completely irregular, or you can say evenly distributed. Irregular pattern means what? Evenly distributed. Here it is not evenly distributed. Here you see in the crystalline solid, here it is 3, here it is 2, here it is 3, here is 2. It is not even. It is following a order, but it is not even. Here if you see on an average, you see this portion is almost filled, this portion is almost filled, this portion is a little bit less filled. So the order is there for a very short range, but it is evenly distributed throughout. So such portions are scattered, and in between the arrangement is disordered. So throughout it is scattered, but the arrangement is not in order, it is in disorder. So that will form the amorphous solid. So what are the examples of crystalline and amorphous solid? quartz and quartz glass. Glass is an example of amorphous solid. Okay, diamond is an example of crystalline solid. So we will see it further. So there will be a lot of examples coming throughout. Now another property of crystalline solids, we will study the properties of crystalline solids, why it has a particular property. So crystalline solids have sharp melting point. Now what does this sharp melting point term means? Sharp melting point terms means that if I say water boils at 100 degrees Celsius, it means it will boil at 100 degrees Celsius only. It doesn't start boiling at 95 degrees Celsius, or it will not start boiling at 105 degrees Celsius. It has a sharp melting point. On the other hand, amorphous solid often soften over a range of temperature and can be molded and blown into various shapes. What does this mean? If you see plastic starts melting when you ignite a flame, it will start melting, and slowly it will get melted over throughout the period. Okay, so this is how amorphous solid works. It does not have a particular temperature over which it will start melting. As soon as you ignite the flame, it will start melting, and throughout the flame it will keep on melting. So you can actually take all the melt and make it a mold, or keep it in a mold, and can form another shape out of it. So this is what it is saying, that it can be molded and blown into various shapes. What does this mean? That so it means something like this. If you melt a plastic, suppose if you are melting a bottle, so if you melt a plastic, then the plastic liquid will be there, and now you pour this liquid in this vessel, so this will take the shape of this vessel. So this can be molded into this shape. So this is what amorphous solid is all about. They can be molded into various shapes, because once you pour it in this, and then you will solidify it by cooling it. So when you solidify it, it will take this shape. So this can be molded into various shapes. Okay, on heating, we are now talking about crystalline solid. On heating, they become crystalline at some temperature. Some glass objects from ancient civilization are found to become milky in appearance because of some crystallization. So if you see what happens, glasses are sometimes you appear that they are in milky in color. Okay, after a very large period of time, they become milky in color because of crystallization. Amorphous solids have a tendency to flow. So these solids are also called pseudo solids or supercooled liquids. Now what does this term mean? If you see a glass, very old glass, you will observe that the bottom of the glass is a bit thicker, whereas the top of it is not that much thick. This is why it is happening, because the components are actually flowing, but it is so much lesser in speed, that it is taking a number of years to finally come to the bottom position. So they are not actually solid, they are pseudo solid, or we can say that they are supercooled liquids. So they are supercooled liquid means these are in the form of liquids, but they are supercooled, so they cannot move, but gradually they are flowing down. So they can take a number of years to flow down, and at the end you will observe that the glasses at the bottom are thicker, but at the top they are thinner. This is because of the movement of these glasses at the bottom. So they are also called as pseudo solids or supercooled liquids. So this is a property of amorphous solids. Now moving ahead, so another property, so we are actually learning side by side crystalline solids and amorphous solids. So what are the shapes of crystalline solids, what are the shapes of amorphous solid? Okay, so we are learning side by side. So again, we had studied that crystalline solid has sharp melting point, but amorphous solid can melt over a range of temperature. Okay, so now in the same run, we have crystalline solids are anisotropic in nature. That is, some of their physical properties like electrical resistance or refractive index show different values when measured along different direction in the same crystal. That means if this is my crystalline solid, okay, and I measure the refractive index of it through this surface, suppose through this surface. So if I measure the refractive of this through this surface, it will have particular refractive index, suppose 1.5. And if I measure the refractive index through this surface, it will have a particular refracting index and it will not be same. So this is anisotropic in nature. Isotropic means same, anisotropic means different. So in different direction, it will have different nature. Why it is so? It is saying here. You see this diagram. This is a kind of crystalline solid. Why? Because you see the red atoms. There are 1, 2, 3, 4, 5 red atoms. Then there are 1, 2, 3, 4 blue atoms. Suppose blue is hydrogen and red is oxygen. So for every 2 hydrogen oxygen there is every 2 hydrogen. So they are arranged in a particular fashion. 2, 2, 4, 5, 4, 5, 4, 5, 4, 5, 4. They are arranged in a particular fashion. Between every 4 oxygen atom there is 1 hydrogen atom. So it should not be hydrogen and oxygen. Suppose it is something else. It is carbon and it is something else. So carbon is forming 4 bonds. Okay. But what is here showing it is that suppose I am measuring a particular property in AB direction. Okay. If I am measuring a particular property in AB direction, I am coming across 4 blue atoms. Okay. And if I am measuring a particular property in CD direction, I am coming across 4 white atoms and 3 blue atoms. Now, when there is 4 blue atoms and in another line there is white atoms as well as blue atoms, so obviously the properties will be different because the atoms are different. And if the atoms are different, so this is another, suppose this is a carbon, this is hydrogen. So carbon and hydrogen are different properties. So if I am coming across carbon while measuring a particular property, suppose electrical resistance, then it will show a particular value. But if I am coming across hydrogen while measuring a particular property, so it will have a particular value because hydrogen has a different nature than carbon. So in different directions, they will have different properties because they are not evenly distributed. They are distributed in a particular order. Whereas what happens in amorphous solid is that the figure is not there in the book, but I am telling you that amorphous solid, the atoms are evenly distributed. Evenly distributed means averagely overall it is distributed. So if you come measure in this line, the same thing will be there as it will be there in this line because they are evenly distributed. So हर जगह सब कुछ मिलेगा, ऐसा है वहाँ पे. तो अगर इधर भी वही मिल रहा है और इधर भी वही मिल रहा है तो दोनों तरफ प्रॉपर्टी का मेजरमेंट सेम होगा. सो इफ आई एम मेजरिंग इन दिस डायरेक्शन for amorphous solid and if I am measuring in this direction for amorphous solid for say electrical resistance, but since the atoms are evenly distributed, so I will come across the particular atom n number of times in this direction, also n number of times in this direction, so I will end up with same value. Okay, so crystalline solids are anisotropic in nature, that is some of their physical properties like electrical resistance or refractive index, so different values when measured along different directions. But amorphous solid are isotropic in nature. Amorphous solid on the other hand are isotropic in nature. It is because there is no long range order. Order है ही नहीं. They are all evenly distributed and the arrangement is irregular along all the directions. All directions में irregular है. That means even है, completely even है. So the properties will be same and it is called isotropic. Isotropic means सब same है, हर side same है. Isotropic. Anisotropic means हर side अलग है, हर direction में अलग है. Okay, so you remember this thing, very important. Crystallines are anisotropic in nature, amorphous are isotropic in nature. Again, this arises from different arrangements. So it is saying the same thing that I have shown in the figure. This arises from different arrangement of particles in different directions. Since the arrangement of particles is different along different directions, the value of same physical property is found to be different along each direction. Means the same thing that I have explained here in this figure. Okay, so moving ahead, now there is a table just so that you can remember the thing. So the properties are there in this left hand side and it is for crystalline solids here and for amorphous solid here. So first we will study like this and then we will study like this. So let us study about shape. So crystalline solids have definite characteristic geometrical shape. That means if a particular crystal is hexagon, finally a crystal will form, a lattice will form. But amorphous solid, they are irregular in shape. Some crystal will be diagonal, some crystal will be polygon, some crystal will be pentagon, some crystal will be octagon, and they will be forming. Okay, so they are irregular shape. melting point. Again, they melt at sharp melting point. If it is said that copper will melt at 1083 degrees Celsius, then it will melt at 1083 degrees Celsius only. If iron melts at 1866 degrees Celsius, it will melt at that temperature only. But if plastic, it will start melting as soon as you apply the flame, and it will keep on melting over a particular range of temperature. Okay. Cleavage property, it means the cutting property. So if you try to cut it from here, it can get cut only at a particular angle. So when cut with sharp edge tool, they split into two pieces, and the newly generated surface are plain and smooth. Now what is it talking about is this thing you see. So this is my Rubik's cube. Okay, this is my Rubik's cube. This is my Rubik's cube. There it will be there also, isn't it? So 3 dimension it is. Okay, I am drawing it for you. This is my Rubik's cube. Now I want you to know that these are all small cubes, and it is combining there. So if I cut here, then what I will get? I will get another cube, isn't it? And the overall shape of the Rubik's cube is also a cube. So when I cut it, I will get a cube only, and its overall shape is also cube. So this is what it is saying here, that when cut into with sharp edge tool, they split into pieces, and the newly generated surface are plain and smooth. When cut with sharp edge, they split into two pieces, and the newly generated surface are plain and smooth. And also they have this line is missing here. They will have the same structure as they are in the original piece. So if you cut in here in the piece with a knife, so a plain surface will be generated, which will be smooth in nature. So it will be cutting like this only. Okay, it can cut only smoothly, and it will have a very sharp surface when you will cut it. In the case of crystalline solid. But when cut in pieces, they cut into two pieces with irregular shapes. That means their shapes will not be in the form of the actual shape that they are in there. Example, a coal you take. So if you cut a coal in various shapes, then every piece is actually a coal, but every piece is in the different shapes, isn't it? But if you cut a diamond, then you know why it is said that हीरे की पहचान जौहरी को ही होती है. Why? Because diamond crystals have a particular shape. Okay, and only the Johar can see that shape with the help of that lens. So if that particular shape is there, that means it is diamond. Otherwise it is not diamond. So even if you break the diamond into various pieces, every piece will have that particular shape only. Then only it will be called as diamond. So if you break diamond into different pieces, all the pieces are also diamond only, no? They don't form plastics or something. So they are diamond because that each piece will have that shape only. The crystal shape of the crystal or the shape of the lattice will be that only. But if you break coal, so you take a spherical coal and you break it into pieces, and some pieces rectangular, some pieces cuboidal, some pieces orthogonal, some pieces rhombohedral. So the pieces will be different in nature, different in shape, and their crystal structure will also be different in shape. So they are also coal. When coal broken into coal, then they are also coal, but their crystal structure is not the same as that of the parent coal. But if you break diamond into pieces, their crystal structure will be that of the parent only. That is if they are arranged in a hexagonal fashion, then each crystal that is broken will also be in the form of hexagonal fashion only. Okay, so this is what it is saying. Heat of fusion. What is heat of fusion? Amount of heat given to make 1 kg of a particular substance. So they have a definite and characteristic heat of fusion. It means what? Since I said already said that they have a sharp melting point. So if you have a sharp melting point, that means you have a particular heat of fusion. That is, I will give 1 kilojoule of heat. SI unit of heat is joule. So if I give 1 kilojoule of heat, then it will completely fuse. So it will convert from solid to vapor. But in amorphous solid, it is not the case. In some cases, it can take 1 kilojoule. In some cases, it can take 0.5 kilojoule. In some cases, it can take 1.3 kilojoule. So they do not have definite heat of fusion. Anisotropy. Anisotropic in nature, crystalline solid we have studied. It is amorphous is isotropic in nature we have studied. So crystalline solids are called true solids because they will stay in their form. But amorphous are called pseudo solids. Why? Because they are actually liquids, super cooled liquids, and they can generally come down after a very long period of time. As we talked about glass, it has thicker base and thinner top, isn't it? Okay. Order or arrangement of constituent particles, it is long range order we have studied, and it is only short range order. So these are the things, these are the properties that we studied about crystalline and amorphous solid. Now moving ahead. So crystalline solids, again there are various kinds of classifications. Why these classifications come? Because there can be molecules or there can be ions, isn't it? So depending upon the forces of attraction between the molecules, there is again the classification of crystalline solids. Because if they have very high force of attraction, then they will have a particular property. They will not be broken easily. They cannot be melted easily. But if they have least force of attraction, but at the same time they are solid, then they can be broken easily. They can be melted easily. So depending upon the forces of attraction, or depending upon the nature of force that is holding them together, the crystalline solid is further divided into molecular solid, ionic solid, metallic solid, and covalent solids. Okay, these are the four classifications depending upon the nature of bond. Now these figures are just for representation, so just to make the slide so good. Let us come to molecular solids. Again, molecular solids are further divided into non-polar, polar, and hydrogen bonded. Now at this point I would like to know, or rather confirm, that you have revised your 11th chemistry. So you know the octet rule, that every atom in this universe will try to complete its octet. That means 8 number of oxygen in the outermost shell, that is valence shell. Remember, no? And in case of hydrogen, it will try to complete 2 electrons in the valence shell. So 2, 8, 18, 32, 2n square rule we know. Now, and that is how in the quest of completing the octet, the molecules are formed. That is 2 atoms combined together to form molecules, and in some case they share their electrons to the neighboring atom, and that is how they form ions, because this becomes positive as it has shared electron, and that will become negative because they have gained electron. But in some cases they are not able to completely transfer the electron, so they share their electrons. So I will keep one of myself and you will give mine, and this mine electron will also be yours too. So there is a mutual understanding is there, and this is how a covalent bond is formed. So now let me give you an example. So atomic number you have to remember at least till calcium. Calcium atomic number 20. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, till 9 I remember. I am telling you. So after 9 I remember till 32. I can tell you till 32, okay? But I don't want to tell you because the lecture will lengthen. So you remember till 22 hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, okay, chlorine 17, argon 18, okay, and potassium 19, calcium 20, scandium 21. Okay, I don't want to go further. So let us see how is hydrogen chloride formed. Hydrogen atomic number is 1. That means the number of electrons here will be 1. What is atomic number? Atomic number is number of protons present inside an atom, and number of protons is equals to number of electrons. You know this, no? So hydrogen has atomic number 1. This means 1 electron is present in the outermost cell. And calcium has atomic number of 17. So how many electrons will be present in outermost cell? In the innermost cell 2 electrons. 2, उसके बाद आएगा 8 इलेक्ट्रॉन, भर लेगा 2 8 10, बचा कितना? 7 इलेक्ट्रॉन्स. तो क्लोरीन के लास्ट सेल में कितना होगा? क्लोरीन के लास्ट सेल में होगा 2 2 4, these dots are electrons, 2 6, and this 1. This single electron is there. Hydrogen has 1 electron here. Now hydrogen wants to complete its duet, chlorine wants to complete its octet, so they will come together and marry each other. So this is chlorine completing its octet, and this is hydrogen completing its duet. And this portion that you are seeing, my brother, here, this is our covalent bond is formed, we say. Okay, so this is how a covalent bond is formed, and we write it as HCl. Since it is 2 electrons, so it is single bond. Okay, so this is how a covalent bond is formed. Okay, so this is a bond. Okay, so I just reminded you how a bond is formed. So this is not complete revision, this is just a glimpse, so that when I am telling something, so yeah, it doesn't pass over your head. Okay, so now let us move forward. Okay, so I will not move forward here. I will stop the lecture here, and I want you to just revise this thing. Okay, and then in the next lecture we will study about molecular solids. Okay, thank you.